All right, so we're going to talk about how do we find slope if we're given 2 points now. We know graphically, if you think about slope, so for example, number 1, we are given the ordered pairs of 12, 17, and we are also given negative 13, negative 15. Okay. If we were to graph this, we would end up having, I'm just going to draw this approximately, but if we were to graph it, we could say, okay, we'd have a point at 12, 17, this is x-axis, y-axis, and I'm just doing approximations here, and then negative 13, negative 15. Okay, so somewhere around here. Again, this is just an approximation. Okay, so if we look at this line, we would want to figure out what is our slope? How steep is this line going to be? Well, we can see right away that it's going to have a positive slope because our line is going up. But what we need to figure out is how much do we go up by, and then how much do we go over by. So what we're going to do is we can use a formula to figure that out. When we're thinking about how much do we go up by, we could say, well, that quantity or that amount could be y2 minus y1 over whatever x2 was minus x1. So usually what I recommend to students is when you're working with this is label your points. So the first point is going to, you know that an ordered pair is always x, y. I'm going to actually rewrite this over here so a little bit more space. So 12, 17 and negative 13, negative 15. Okay, so we know that our first ordered pair is always x, y, so I'm going to label this x1, y1, and this will be x2, y2. Whenever you're finding slope using 2 ordered pairs, you always are going to be using this equation. M represents slope, so it's m equals y2 minus y1, remember how we talked about that over there, all over x2 minus x1. So this is going to be really important. You might want to go ahead and put this in your notes. This is a very, very important thing to know. Maybe you want to put a box around it and then star it. Okay, this is to find slope. So in this instance here, let's find our slope. So we want to say y2, so it's going to be negative 15 minus 17, that's y1. x2 is negative 13 minus x1, which is 12. So we do our math. We are going to end up with, let's see, negative 15 minus 17 if you need to. Remember, you can add the opposite. And we're going to get negative 32. Negative 13 minus 12 is going to be negative 25. And we want to see if we can reduce this at all. It doesn't look like we can reduce it except for we know we could divide the top and bottom by negative 1. So our final answer would be 32 over 25. All right, let's look at another example. Just trying to see if there's any specific ones that are going to give you issues. We can just go on to number 2. So look at the problem for number 2 here. And I am going to put in some lines so I keep it a little bit more neat here in my work. All right, so number 2. They gave us the ordered pairs of 1, negative 15, and they also gave us 19, 14. Okay, so again, first thing is you want to label them. I'm going to label x1, y1, x2, y2. And then remember that we're using the formula m equals y2 minus y1 all over x2 minus x1. Alright, so y2 is 14. Y1 is negative 15 all over 19 minus 1. So on the top, remember when we subtract, it's really just adding the opposite. So it's going to become 14 plus 15, which is 29, all over 18. We can't reduce it, so there is our final answer. So it's just the same pattern with the rest of the problems. If you have any questions, feel free to ask me.